So this session is about deploying Windows 8.1, what's new. In the next hour or so, we want to talk about three main areas. We want to talk about OS deployment, app deployment, and infrastructure deployment. As usual, most of the time we're doing a session like this, we spend 75 minutes on this, so we're going to try to squeeze that into an hour-long session and hopefully still have a little bit of time for Q&A. So we'll try to go through this as quickly as we can. So first, let's talk about operating system deployment. When we first talk about OS deployment, the main concern is around compatibility. And from a compatibility perspective, Windows 8.1 doesn't change the hardware requirements for the most part. Now we say in a little footnote that yes, there are some changes to the hardware requirements, but they're fairly minor overall. There are some specific processor capabilities that are required to run Windows 8. And also some new ones that are required to run Windows 8.1. To run Windows 8, the system has to support, the processor has to support NX, PAE, and SSE2 instruction sets in the CPU. Windows 8.1 adds in a requirement for some additional processor instructions that mean that 99.9% of the hardware that's out there will support Windows 8 and Windows 8.1, but there will be a few systems that won't be able to run Windows 8 or 8.1. In the case of Windows 8, the biggest one that people have run into is VMware. VMware 5 doesn't support the necessary processor instruction set required to run Windows 8, so you need to upgrade to something later than VMware 5. In the case of the Windows 8.1 requirements, the biggest change is in regards to Pentium 4s. How many of you are still running Pentium 4 systems? Well, if you are, you won't be able to run a 64-bit version of Windows 8.1 on them. You'll only be able to run an x86 version on them. Otherwise, pretty much everything else remains the same, and you'll be able to run Windows 8 or 8.1 on anything that supports Windows 7 or above. Same CPU requirements, same memory requirements, same disk space requirements. In fact, after you install Windows 8.1 onto a Windows 7 or a Windows 8 system, odds are you'll have more free disk space than you had before you installed the OS, because we've made improvements on the disk footprint for the operating system, even though the image itself doesn't really change in size, and we've added more cleanup functions to make sure that as patches are applied to the OS that it doesn't grow so much over time. So overall, the hardware requirement should be easy, our existing drivers should continue to work, and should be fairly straightforward. From an app perspective, desktop application compatibility is excellent with Windows 8, Windows 8.1, which makes sense. We really haven't changed the desktop environment that much. Most of the changes that we made in Windows 8 and 8.1 is in regards to the new modern application interfaces, the WinRT environment to run these Windows Store apps, the full screen immersive touch-based applications. So all of that is new, but the existing desktop environment isn't affected, and as a result, applications just continue to work. Now, we can't come out and say that it's going to be 100% compatibility because developers always do silly things. It's possible that they would do something that would cause an app to break, but that should be an exception. Most applications should work. If they worked on Windows 7, they'll work on Windows 8 and Windows 8.1. If you're coming from Windows XP, it's still a little bit of a different story. Getting from Windows XP to a modern OS like 7, 8, or 8.1 is going to be a fair amount of work to go through and test out your applications. But if you've gone through that effort to get to Windows 7 or to Windows 8, going to Windows 8.1 will be really straightforward. How many of you are thinking about going directly from, say, Windows XP to Windows 8.1? There's always a few, and that surprises us because, well, we had hoped that there would be fewer on Windows XP, but we will make sure that we can enable those scenarios, and we'll talk a little bit more about that later as we get into this. Modern apps, if you're running Windows 8 today, all the modern apps that run on Windows 8 should continue to run on Windows 8.1. In the case of these modern apps, because we have most of them in the store, we have like 100,000 of them available for us to test, we can run through our tests of all of those existing apps on Windows 8.1 to make sure we didn't break anything, and that gives us a fairly high level of confidence that nothing's going to change in this modern app environment that would break those existing apps. So no concerns there. Internet Explorer 11, there is a new version of IE included in Windows 8.1. That is fairly well compatible with IE 10. So for those coming from Windows 8, no big deal. For those of you coming from Windows 7, you could be running IE 8, IE 9, IE 10 on Windows 7. Most of that should be fairly straightforward as you've gone through and fixed up the applications to make them work with IE 8, IE 9, IE 10. For those coming from Windows XP, the challenge becomes older browsers. So how many of you are using Windows XP with something earlier than IE 8? Ah, that's a relief to see. No one's using something earlier than IE 8. So as you get to IE 8, you could address a lot of the issues, primarily from the old IE 6 days, but there will be some incremental changes that may be required as you go from IE 8 to IE 11. For the most part, anything that's well-formed HTML5 should be in good shape. There could be some web apps that need minor tweaks, primarily just to tell Internet Explorer, I want you to render this web page following the rules for IE 7, IE 8, IE 9, IE 10. So all of those compatibility modes are present in IE 11. You just need to tell IE because it can't necessarily figure that out for itself. You indicate appropriately that here's the level of support that we need, and IE will take care of the rendering from there. We have made a couple of changes in IE 11, one of which will probably be noticeable if you use any add-ons for IE. There is a new enhanced security mode that causes add-ons to cause a prompt when IE runs to say that it's not these add-ons aren't compatible with the IE security mode, and it will allow you to opt out of that security mode to run those. So you may see that additional prompt. Basically, IE 11 runs the browser inside of an app container, just like a modern application would, to make sure that we can do things like share cookies between the modern browser, the touch-enabled browser, and the desktop browser. We also changed the user agent string in IE 11 so that instead of indicating that it's IE, it actually says that it behaves like Gecko, which is the engine that's used by Chrome. So by making that change, we caused the browser to request web pages that would send the same HTML back that would get sent to the modern versions of Chrome or other third-party browsers. So that we want to see that same rich HTML5 being sent back to IE rather than the special cased IE XML or HTML that's been written over the years to handle the quirks of IE 6, 7, and 8. So overall, there could be some additional testing needed for some of the IE behaviors, but most of it should just be simple tweaks to make sure that the doc type is set appropriately so that IE knows how to render that page. Now, when we go to deploy Windows 8.1, we've got a new mechanism that can be used for those coming from Windows 8. So the path from Windows 8 to 8.1 is designed to be as simple as possible. And to do this, we basically want to take the existing operating system and apply an update to it to turn it into the new OS. For most people doing this from their home, so if you have a home PC running Windows 8, you'll be offered an update through the Windows Store. That update will download from the internet, it'll install, it'll reboot a couple of times, and now your Windows 8 system's running Windows 8.1. That's great for the home user. That's not so good for the enterprise, because the enterprise first doesn't want 1,000 people going out and downloading the update over and over and over again. And second, they want more control over when that update's going to be deployed. Now the first part, well, both parts really are solved automatically if you're using volume license versions of Windows. So any version of Windows 8 that's been volume activated won't be offered the 8.1 update from the store. The assumption is if Windows was volume activated, you want to deploy Windows 8.1 to it yourself. You don't want the store to be offering that to your users. So that would be the first easy way. Make sure that you're using volume activation and the store won't offer the update. If you do have some retail or OEM activated machines, you can deploy a group policy to those machines. Say maybe you have some Windows 8 Pro machines in your environment and you want to block the update. You can deploy a group policy that tells the store, don't offer the update, even if they haven't been activated with VL. So if you're coming through the store, you'll see the store offer that. You'll click the install button. It'll take care of all the work. If you're coming from an enterprise environment, you can do the same type of deployment, but initiate it using something like System Center Configuration Manager. So using a software distribution tool, you push out the 8.1 update to existing Windows 8 systems to do an in-place upgrade just by running a simple command line. The command line is just setup.exe/auto:upgrade, and it takes care of the same work, because it's really running the same engine behind the scenes. It's the same setup engine being used in either case that will take that existing Windows 8 system, update it to Windows 8.1. The process that it's going through is exactly the same. The engine is exactly the same. There's a different look and feel and a slightly different image format that's used in one path versus the other. When it downloads the OS from the Windows Store, it downloads an ESD file, which is just using a different compression method than a typical WIM file would. When you're deploying it yourself using System Center, you're just taking the original Windows 8.1, turning it into a package, and then pushing it out to your existing machines. So let's take a look at what that would look like. So I have an existing Windows 8 machine, and from this Windows 8 machine I can first I want to go to the right place on the start screen. I'll launch the Software Center, and from there go to the Application Catalog. And in this case, I've set this up for self-service, so I can make Windows 8.1 available through Configuration Manager for a user to select. When they select it, it would download the necessary pieces, run the setup engine, and update this 8 machine to Windows 8.1. We'll give it a couple of seconds here to come back with the list of things that I can select from. But the idea is that maybe you want to do kind of a user-driven deployment where they choose when they want to deploy. You could, because Config Manager supports pushing as well, you could just make this a scheduled activity. So maybe they go home at night, they come back in the next morning, and they've been updated to 8.1. So here I have the Windows 8.1 Enterprise x64 bits. I can click Install. Yes, I'm sure that I want to do it. It will connect to Configuration Manager and initiate that deployment. The download of this will happen in the background after all the necessary bits are downloaded. It kicks off the setup engine. It will run through a variety of compatibility checks to make sure that there are no known issues with any apps, any drivers, any BIOS versions, anything that could prevent the update from succeeding. Once it's passed all of those compatibility checks, it will perform the update process. Now that's basically going to take the new Windows 8.1 image, extract it onto the hard disk, kind of moving the old operating system out of the way as part of the process. It will keep all the existing apps, it'll keep all the existing user data, all the accounts, all the settings. Most of it is just left in place on the disk. The exception would be some of the application files and settings need to be moved off to the side and then merged back into the OS at the end. So it's a fairly straightforward process to go through, and most importantly, it's very recoverable. So if anything goes wrong during this process, maybe you hold down the power button, maybe there's a crash that's caused by a bad driver that might be in place, whatever interrupts the process, Windows will be able to detect that failure on the next boot and automatically roll back to Windows 8. So the only time you end up in Windows 8.1 is when you have a fully successful deployment from start to end. It's even to the point where you can boot into Windows 8.1 and it will present an initial choose your settings screen. If you were to power off at that point, it would roll back because it says, well, you didn't complete that choose your settings screen successfully. So there are definitely safeguards in here to make sure that this is as reliable as possible, and also to make it as fast as possible. On a fairly fast machine like a ThinkPad X1 Carbon machine, it can update in about 15 minutes from Windows 8 to Windows 8.1. Now that's a fairly fast machine with an SSD and most of the installation files either across a very fast network connection or already local on the machine. For slower machines, spinning hard disks, slower networks, the time can be much larger, but most of the time we see this process completing in somewhere in the 1 to 2 hour range. So fairly easy to go through, and at the end of the day you're left with Windows 8.1 with all your apps, with all your data, with all your accounts, with all your settings, so everything is left intact. So we'll let that process run along and we can come back and check on that later to see how it's going. Now for those coming from a different operating system, so not running Windows 8, maybe you're running Windows 7, maybe you're running Windows XP, whatever the situation is, those deployments are going to be done with a more traditional refresh. You could choose to do that if you're running Windows 8 today, but we think it would be easier to use that update process to go from Windows 8 to Windows 8.1. That update process isn't really applicable to the other cases, so XP to 8.1 or Windows 7 to 8.1. You could actually do it, but it would only migrate user data. It wouldn't migrate apps. And without the apps, well, you're going to have to reinstall all of those anyway, so at that point you might as well do the more traditional OS refresh. Using something like MDT, using Configuration Manager to automate all the necessary steps that are involved, which involves running USMT to capture all the data and settings, removing the old OS, laying a new OS down on the system from the WIM file, reinstalling the apps, restoring the data and settings, and now you're set to go. So that process can be done using our existing deployment tools, all of which are being updated for Windows 8.1. There is a new ADK. The new ADK for 8.1 actually was released yesterday, so you can find that on the Download Center now. It supports installation now on Windows Server 2008 and above, so that R2 part has been scratched off of there. So if you really wanted to use an older deployment server, you can do that. Microsoft Deployment Toolkit 2013 is the version that will support Windows 8, Windows 8.1 using the new ADK. That is in preview right now. The final release of that is expected in October. So at general availability, we'll have all of these new tools available, except for the ADK that's already out. Configuration Manager 2012 R2 also has updates in it to support the new ADK and to support Windows 8.1. That's out in preview as well right now. The final release of that is also expected in October with the GA release. So the goal with this is that at GA we want all these tools to be ready so that there aren't any subsequent delays. While we do have the RTM bits available right now for Windows 8.1 Pro and for the ADK with Windows 8.1 Enterprise coming later this month, they're not really considered done because we're still working on bug fixes, additional enhancements, really trying to get the operating system fully ready for that October state. So when October comes, we'll be releasing another update. Be a fairly large update. We don't know the exact size yet, but it will generally be pre-applied to the operating system image, and you'll want to create your gold image of the operating system using that image that we release in October. So you can get the RTM image today, but we wouldn't expect that's what you're going to use to build your final golden images for your 8.1 deployments. Now the new ADK does include some new tools. It includes a new version of Windows PE. Minor changes overall. The biggest challenge is that it's the same as Windows PE 4. It does require hardware that supports Windows 8. So if you're planning to still do deployments of, say, Windows 7, and you have some older hardware that doesn't meet the requirements for Windows 8 because they don't support NXPAE or SSE2, well, you're going to then have some problems. Windows PE4 and Windows PE5 won't even boot on those systems. In the case of Configuration Manager 2012 SP1, CU2 or CU3, one or the other, they added the ability to use Windows PE3 back into the product for those older machines. So you would use that older version of PE to deploy Windows 7, and then use Windows PE4 to deploy 8 or 5 to deploy 8.1. There is a new version of the User State Migration Tool, version 6.3. It adds support for Windows 8.1 and Office 2013. The complicating factor is it removes support for capturing user state from XP and Windows Vista. Well, we talked before that there's a few of you in the room that want to be able to go from Windows XP to Windows 8.1 directly. How do you do that if USMT 6.3 doesn't support capturing user state from XP and Vista? Well, the scenario that we want to implement, that we're still working on the documentation for, is using USMT5 to capture the user state from XP and Vista, and then restore that user state using USMT 6.3. So USMT5 supports capturing on XP and Vista, where USMT 6.3 supports deploying to Windows 7, Windows 8, Windows 8.1. So by using those two together, we can complete that scenario. In my session tomorrow afternoon, I hope to demo that, which means I have from now until tomorrow afternoon to get that working. So come to the session tomorrow afternoon to see if I've figured it out by then. Okay, the last item, the Deployment Image Servicing and Management Tool, also called DISM, has a couple of minor changes. One is that you can export an image in a special compressed recovery format, not terribly interesting by itself. But it also adds a new option to kind of shrink your OS down. There's an option that was present in Windows 8 called Start Component Cleanup, which would remove old versions of OS components after you had applied patches to the OS. So you install the OS, you apply a bunch of patches to it, you then run this command and it shrinks the OS back down to a smaller size. The challenge with that is it didn't get rid of all of the older components. It never got rid of the original version of the component. So if you had, say, IE in the original OS, and then you applied a patch, and then you applied another patch, well, when you ran the cleanup, it would only remove the middle version. It would keep the latest version, it would keep the original version. With Windows 8.1, they've added another switch called Reset Base. That Reset Base says, you see that third version? Treat that as the new base version and clean up the version 2 and version 1 that were present in the image. So fairly easy to run this command as part of your image creation process to specify dism/online/start component cleanup/reset base, and I think there's /quiet/restart or no restart or some other options that need to go along with that. But basically you run that command to shrink the OS back down to its minimum size. So let's look at one other scenario with MDT. This is our previous deployment. It's now booting into Windows 8.1, so let's move that one out of the way for now. And let's switch to a Windows 7 client. So for a Windows 7 client, we can use MDT to initiate a refresh from Windows 7 to Windows 8.1. This is running MDT 2013 with the new ADK. You won't see any real drastic changes in MDT 2013. It's a fairly minor release overall. Tomorrow afternoon we'll talk more about the extent of the changes that are in there, but it's a fairly easy upgrade for those that are currently running MDT 2012 Update 1. So here I can choose my Windows 8.1 task sequence. Can join it into the domain, automatically migrate data, don't do a backup, specify my time zone, any apps that I want to install, and start off the process. So it's the same basic MDT light touch deployment that we would generally go through, where it will run USMT to capture the user state, apply a version of Windows PE to the hard drive, reboot into PE, wipe the old OS, lay down a new image, boot into the new OS, reinstall the apps, restore the user state, and off we go. So no big changes, no big surprises there. The behavior is pretty much exactly as you would have seen today. Now, as far as changes, for those of you who haven't yet done a whole lot of work with Windows 8, you'll definitely want to investigate UEFI, especially if you're buying new Windows 8 logo certified machines, because UEFI effectively gives you two big benefits. One is going to be speed, and the second is going to be security. From a speed perspective, it's going to be much faster to boot Windows 8 or Windows 8.1 from a UEFI-enabled system. The goal with these systems is from the time you hit the power button until the time the OS starts to load, should take about 2 seconds, and then the operating system will start to boot up, and the operating system should be able to boot on an SSD drive in another 15 to 20 seconds. So from the time you hit the power button until the time the system is fully booted from a cold start, 20 to 30 seconds should be all it takes. With some systems, it can be even faster than that. If it's a system that's been sleeping, it's going to be nearly instantaneous, so this is really only the cold boot case. But using UEFI enables the OS to be read from the disk and into RAM much, much faster than was possible before. In the case of security, Secure Boot is a feature of UEFI that enables the firmware to validate the signatures of the files that are being used to boot, so the OS can't be infected by malware or rootkits before it can defend itself. So that provides that extra level of protection to make sure that that malware can't get hooked into the OS before any type of early launch anti-malware detection can be run by Windows itself. We also have tablets to concern ourselves with. If you've done any tablet deployments, there are some things to watch out for there. The main things are that these may not have wired network connections, so you may need to use USB network adapters. They won't have an on-screen keyboard inside of Windows PE, so if you need to type in computer names or passwords or anything like that, you'll need to attach a USB keyboard to the device. They will have touchscreen support, so you can touch the screen and use it like a mouse, but there will be a set of tools that you need to help out with these devices. These devices also typically support Instant Go. Instant Go is, well, it used to be called Connected Standby. It's basically the ability for Windows to go into a deep sleep mode where apps continue to run in the background. So basically works like your phones work today. When you turn them off, they're never completely off. They still receive phone calls. They still download things in the background. So that behavior on a Windows 8 tablet, which will also now be extended to the new Haswell and Bay Trail based tablets that will be coming out here shortly, requires that you have the appropriate drivers, because driver support for connected standby is very critical to make sure that the battery drain by these background activities isn't going to drain the battery any faster than it absolutely has to. So it's very important to get the right drivers in place. So definitely pay attention to the exact driver set that the OEM says that you should use. Windows To Go is also a new capability that was added in Windows 8. It's been improved in Windows 8.1 to turn the Windows Store back on. There were some licensing challenges with that before, which is the reason that it was turned off, but now it's been enabled. But this is basically Windows running from a USB key, so carrying around your complete Windows environment on a USB key. Great scenario, very easy to set up. It does require software assurance because it's only supported with Windows 8.1 Enterprise, but basically you run through a wizard, it puts the operating system onto the USB key, you put it into a system, you boot it up, and it's just like Windows is running from the hard drive, except now it's completely portable.
The upgrade to Windows To Go from 8 to 1 the same way?
You can't actually upgrade Windows To Go. That was one of the limitations discussed in the initial Windows 8 documentation. Basically, you would have to build a new Windows To Go stick with Windows 8.1, and hopefully you have some type of cloud backup system in place for your data and settings so that they roam back down to the device, which is really a key design feature that you want to provide anyway, to make sure that if that device is ever lost or broken, that you can easily recover it by giving the person a new one, and everything gets pulled back down from the cloud or some type of on-site server. But you can't upgrade Windows to Go directly. You would have to build a new stick. So when we talk about apps, the main concerns around app deployment really are around modern apps. So how do we deal with this new Windows Store? And there are a few things that we'll talk about that we've improved in Windows 8.1, but for enterprises, we would expect to use a process called sideloading, where sideloading is where we can use something like Configuration Manager or Windows Intune to install an app on a Windows 8.1 system without having to pull it from the Windows Store. So your developers have built an application, they have the AppX file, they want to deploy it to systems inside of your organization. You can do that. That's provided automatically with software assurance with Windows 8 Enterprise, Windows 8.1 Enterprise. If you're running another OS like Windows 8.1 Pro or Windows RT, enabling sideloading does require installing a separate sideload product key. That sideload product key is provided for free as part of the software assurance benefits. If you don't have software assurance, you can purchase those sideload keys for somewhere around $30 a piece US. Forget what that translates to in New Zealand dollars, but they're sold in 100 packs to permanently enable sideloading on a particular operating system, on a particular device. You can install apps via sideloading, which basically makes them available for the current user. You can also provision apps on a machine by really making them available to all the users on that device. So provisioning registers the app on the device and then automatically installs it for every user, whereas installation only installs it for a single user. This is definitely different than the behavior of any apps that you've deployed before on Windows. It's not the same as the existing MSIs or setup.exes. These things always install silently. They don't require admin rights. There's just some different behaviors that you need to be concerned with. There are also some differences around certificate behaviors, because these apps will be signed with a certificate. That whatever certificate was used to sign the app needs to be trusted by Windows before it will actually allow that app to run. So it doesn't matter what certificate your developers use, as long as that certificate is chained to a trusted root certificate that you've already deployed to all your computers in your organization, or if you haven't done that, that they can give you that trusted root cert so that you can deploy it to the computers. We could spend an hour just on this one slide, getting more in-depth on this, but we don't have that time, so we'll leave it like that with apps and talk a little bit more about some changes in Windows 8.1. First, we've enabled automatic application updates. So if you've installed Windows 8, you've noticed that the store would occasionally show a little number on it to indicate updates were available. You'd launch the store, you'd click on the available updates link, you'd see the list, you'd select them all, you'd click the install button. That process would happen 3 or 4 times a week, depending on the number of apps you have installed. But as updates would come out, Windows would tell you that they're there. You had to go through that same set of activities to install them. Launch the store, available updates, select all, install. That's really tiring. So in Windows 8.1, that process has been automated to automatically download and install all application updates. There is a group policy that you can use to control that. You can disable that if you want, but it's enabled by default so that now users don't need to do that. They'll just download in the background and install whenever they're available. For the inbox apps, you never needed a Microsoft account to install updates for the inbox apps. That's still true. One of the interesting changes, though, is because these app updates can install in the background automatically, they can install even when the Windows Store has been disabled. So one of the challenges before is some enterprises would say, well, we don't want to enable the store for our users. For at least some of them, we want to turn the store off. But if the store's off, they don't have any way to install updates for the inbox apps. We want them to be able to use the latest versions of the inbox apps. How can we solve that problem? Well, with 8.1, you can do that by disabling the store for the current user and enabling automatic updates. So the automatic updates still flow down even with the store disabled. If you don't want that to happen, you can still disable the store at the computer level, not at the user level. There are two different group policy settings, but if you disable it at the computer level, then no updates flow down and the user can't get into the store at all. So some new changes there. We're also working on a way that we can provide packaged versions of the inbox apps so that you can put those into your image so that when your image is shipped out to your users, they don't immediately have 15 updates that need to be installed. In the case of Windows 8.1, we're now up to about 20 inbox apps, so it would be probably 20 updates that need to be installed. But we'll provide MSI files that you can add to your imaging process to inject the latest versions of those Windows Store apps, the inbox ones, things like the Mail app, so that they can be pre-installed before the OS is shipped out. We've also fixed issues with proxy servers. If you've used Windows 8 in an environment that has a proxy server, especially one that requires authentication, that didn't always work well. In fact, that rarely worked well. We fixed that in Windows 8.1 so that it now handles pretty much any proxy scenarios that you throw at it. That includes the Windows Store, that includes the API levels of just things that applications can leverage, and also application updates. So we've adjusted all of our inbox apps to handle proxy authentication as well. There may be some additional changes required by third parties so that third parties can know what to do when they get a proxy authentication challenge back. So you may see that there are some app updates required for that, but all of the Microsoft apps have been updated to handle that. From an infrastructure perspective, the things that we need to be concerned with there are how do we manage Windows 8.1? So what do we need to do to make sure that we can manage 8.1 inside of our enterprise? First, we need to make sure that our management tools support the new OS. In the case of Configuration Manager, the Configuration Manager R2 release, the System Center 2012 R2 Configuration Manager release, will fully support Windows 8.1. You will be able to manage it, though, with earlier releases. So if you're running Configuration Manager 2012 SP1 and aren't immediately ready to go to R2, you can install a hotfix on top of 2012 SP1 to add support for Windows 8.1. That hotfix should be available around Windows 8.1 GA, and will add the manageability support. That won't give you OSD capabilities. So if you want to use Config Manager OSD to deploy Windows 8.1, the only option then is to go to Config Manager R2. But just for bare, simple manageability, it'll be fine to run 2012 SP1. It still remains to be seen whether we'll be able to release an update for Config Manager 2007. How many of you are still running Config Manager 2007? Number's getting smaller, which is good. We really want people to move from Config Manager 2007 to 2012 because it has so much better support for all the scenarios that we already talked about around sideloading, about targeting apps to users instead of to computers. All of the new manageability capabilities in Windows 8 and Windows 8.1 are going to be supported with 2012, whereas 2007 you're just going to get the basics. You're going to be able to do software distribution, you're going to be able to gather basic inventory. So we need to get everyone moved over to 2012 and then to R2 to fully support 8.1. There are also some changes around MDOP. So if you're using MDOP today, there'll be updates to support 8.1. There'll be AppV 5.0 SP2 and 4.6 SP3, which adds support for Windows 8.1 as a client. The new version of UEV 2.0 adds support for basically capturing the settings for Windows Store apps and moving those to the State Store shares. And there'll be a new version of Dart that gets released to support the new version of Windows PE in the new ADK and the new OS, so they all kind of go together. You need a new version of Dart to support the new PE and the new OS. So all of those will be released at the Windows 8.1 GA timeframe, so probably somewhere in October. Finally, there are new group policy settings available. There are some settings around the control of the start screen where you can actually lock the start screen layout. So you can go into a Windows system, you can configure the start screen the way you want, and then run a PowerShell commandlet to export that to an XML file. You can then take that XML file and configure a group policy that says, for these users receiving this GPO, this is what I want the start screen to look like. And it will configure the start screen with that layout and not allow them to make any changes. So that's the control aspect of it. We've also simplified the start screen layout configuration that you would go through for image creation scenarios. So you just want to specify, here's a default start screen layout that all users should start from, and I want them to then be allowed to make changes. We'll go over that one tomorrow afternoon just to see how you would do that. But it's fairly straightforward. You can lay out the start screen the way you want, export it as a binary file using PowerShell, copy that binary file into the OS either as part of your image or at deployment time, so that then when a new user logs in, that becomes the basis for their initial start screen layout. So not too bad, easy enough to do. There are some features in Windows 8.1 that do require Windows Server 2012 R2. There's a new capability called work folders. Work folders is basically the next generation of offline files. So you can set up a work folder share on a server, specify the users that you want to be able to access that, and anything that they drop into that folder on their personal workstation automatically gets synchronized into that file share. But instead of using SMB, which is what offline files used before, it uses HTTP. As a result, this can be passed through firewalls much more easily. You can publish these work folder websites through your firewall and allow users to synchronize data to all of their devices. These can be domain joined devices, these can be non-domain joined devices. It doesn't really matter. So we can support the well-managed environment with domain joined machines and group policy pre-configuring these. Or if you're on a non-domain joined machine, just type in your email address. It will discover your work folder server, which is a simple DNS lookup. It'll then make the connection to that server and automatically set up the synchronization to run in the background. So work folders becomes another option where you have SkyDrive for personal data primarily, SkyDrive Pro for your SharePoint sites to be able to synchronize with data that's on those, and work folders to be able to synchronize with a file share. There's also Workplace Join. Workplace Join also has some requirements on Server 2012 R2. Basically, this is a mechanism that you would use for registering a device into Active Directory for the purpose of using the identity of that device to restrict or grant access to data. So you would use this as part of dynamic access control to say, this user on a trusted device can access this data. This user on a non-trusted device can't. So now you don't have to say the user gets access or doesn't get access and then worry about, well, are they going to be accessing this from a trusted device or not? Now we can throw in the idea of a trusted device into that dynamic access control equation to make sure that we can only allow the data to be transferred or accessed from trusted devices. So very much a security feature to enable dynamic access control from trusted devices. There are also improvements for remote desktop to improve compression and bandwidth and reconnect speeds. We've also added back shadowing support so that an administrator can shadow another user's remote desktop connection. All of those require the latest Server 2012 R2 backend in order for that to work. We've made enhancements for volume activation. Basically, the behavior is going to be the same, so no real changes in functionality. You would need new KMS keys, new MAC keys, because it is a new version of the OS, so you need new keys for that. There will be hot fixes for KMS so that you can run down-level OSs for your KMS servers. It'll be supported automatically with Server 2012 R2 or Windows 8.1, but if you wanted to use any of your existing KMS hosts, you need to install the hot fixes before you can install those keys. Those keys will be available in October at general availability. So in the short term, if you get Windows 8.1 now, you'll have to do Mac activation using MSDN Mac keys, but with GA in October, you'd be able to get a KMS key and the hot fixes to do KMS activation. There are some schema updates, so we have updated the schema for Workplace Join to add some new object types. There is a new feature called authentication policy, which is basically a way to restrict users to certain machines, which kind of brings back a feature that I think was there in Windows NT 3.5 and then went away, and now it's back again. So you can put a restriction that says these users can only log on to those hosts, but in order to do that, you need the necessary domain functional level and the schema level that goes along with that. There's also a schema change that was made in Server 2012 to add support for a new activation type called AD activation, which basically allows your Active Directory to be used instead of KMS. So you can activate your AD and then all your clients would just query AD for the activation blob, which is just an object inside of your AD. So they wouldn't need a KMS host at all. That's only supported by Windows 8, Windows 8.1, and Office 2013, and the Server 2012 and 2012 R2 OSs. So you could use that AD-based activation for the new OSs. You may still need to have KMS around for Office 2010, Windows 7, and also for any non-AD joined machine. So if you need to activate a workgroup machine, you'd still want to keep KMS around for that. We talked about the proxy issues. Basically, Windows 8.1 will work properly with proxy servers, including ones that do authentication. There may be additional application updates required. The main thing, though, is from an implementation perspective, it should just work. So if you specify Internet Explorer proxy settings, those Internet Explorer proxy settings will automatically be picked up by all modern applications. There's no additional policies that need to be set. If you watch it real closely, looking at it with a registry monitor or something like that, you'll see that the proxy settings are actually getting copied to additional places on the system so that the different parts of the APIs know how to find the right settings, but all of that's transparent to you. You don't need to worry too much about it. And it is 11:31. That gives us a few minutes for Q&A. Let's actually switch back and see where our migrated systems are. Our Windows 7 client is still in the middle of the OS installation process. Our Windows 8 client is currently at a black screen, so it'll be back up and running in a little bit. It's going through some hardware detection at the moment. But while those two continue to run along, any questions? Sure. Right.
Presumably that would stop the upgrade if something's not compatible or the user able to continue. The question I had was, if you are doing it as a required type deployment, does it still run those checks?
Yes, so the question was, if you're doing it user-based, it'll run through compatibility checks. If it doesn't pass the compatibility checks, it will force the process to fail, so the user can't choose to move forward. If you're doing this completely unattended, so you're trying to push out the update, the same checks will run, and if the checks don't pass, the process just fails with a non-zero return code. So you'll be able to see through your config manager reports, these are the machines that failed. You'll have to look at the Windows setup ACT log to see why it failed, so what didn't actually pass. So there's no simple way to be able to tell that this error number means this was the failure encountered. It's going to be more like a generic error number and check the logs to see what the incompatibility was. Sure.
Upgrading to ECC in 2012, what's the upgrade path from that to 2012 R2 like?
So what's the upgrade path from Config Manager 2012 to 2012 R2? Basically, it's like a service pack. So if you went from Config Manager 2012 to SP1, the process of going from SP1 to R2 is exactly the same. Almost exactly the same. Because first you're going to need to uninstall the previous version of the ADK, the ADK for Windows 8, which was required for SP1, and then install the new ADK for Windows 8.1, then install the R2 version itself, which takes care of generating new boot images and all that good stuff, and then you'll have to push out the new Config Manager R2 client to all your existing machines. That's pretty much it. You're all set. Are there any new group policy INF files? You know, I haven't looked to see where the new settings are, but there are definitely new settings. Whether they're to existing INF files or there are new INF files, I haven't looked in any detail, but my guess is that they're to existing files and not to new ones, but you will definitely want to update, if you have a central policy store, update that store to the latest INFs or ADMXs that are included with 8.1. There are definitely policies around the start screen to configure, do you want to boot to the desktop instead of going directly to the start screen? Do you want to go to all apps instead of to the normal start screen? Do you want to view by category? Do you want to use the desktop background? So all the new start screen UI capabilities are all controlled via group policy, so there are definitely policies around that.
So you've addressed Microsoft has addressed the proxy issues with modern apps, which is awesome, because that's broken up. But the other thing that's broken up about modern apps is the insistence that UAC must be turned on before the thing will run. Is that still the
Yeah, so the comment was proxy server fixes are good, but UAC requirement is bad. That doesn't change. With Windows 8.1, to run modern apps, there are a couple of things that you can't turn off. One of them is UAC. The second is the Windows firewall. Both of those are required in order to run Windows Store apps. Now, with UAC, you get a slider that you can turn it all the way down to basically say automatically accept all elevation prompts, which is on good enough to run the modern apps. Now, it's not buying you anything from a security perspective, but it satisfies the requirements. So you don't have to turn off UAC completely. You can just turn the slider down to 0, basically, to say, never prompt me, just always automatically elevate. The firewall requirement, you would have to make sure that the Windows firewall service is running. There's no restriction on running additional third-party firewalls on top of that. You can have generic rules in the Windows firewall that say allow everything and let a third-party firewall control all of those pieces, but there are some WinRT API requirements that are tied to both of those. Sure?
Can you deploy ECC image to the Windows Go instance? How do you get the image up to the Windows Go?
So how do you get a Windows image on a Windows to Go stick? There are a few different ways. If you're talking Config Manager specifically, Config Manager has documented a process and provided a tool that simplifies that. Their intended design is basically to turn that into a self-service operation. So the user would go out and buy a USB stick, or they get one through some internal purchasing process, but they get the USB stick. They then go to Software Center, they find an advertisement for Windows to Go, they run it. It'll prompt them to insert the USB key. It'll give them a list of images to choose from. Generally there would only be one, and it would then apply that to the USB key. Now the image that it's actually going to be using is using Config Manager standalone media. So you would take a task sequence, you would take your existing image, you would create standalone media with that, which creates one very large WIM file containing the operating system and the boot images and the necessary hooks to run the Config Manager task sequence when it starts up. So it puts all of that on the USB key. When the USB key is booted up for the first time, it will contact the let's take that back. It'll run the task sequence. The task sequence will customize the operating system, inject drivers, apply updates, join the machine into the domain, all the normal task sequence activities. After that's done, it then boots into the full OS, and you have a stick that's ready to go from that point. So handled pretty well from a config manager perspective. The other ways of doing that are via a creator wizard that's included in Windows 8.1 Enterprise. You just run the wizard, and it's the same look and feel that you would get through config manager because it's the same code. Basically, it knows how to prompt you for point me to your WIM, point me to your USB key, and it goes through all the same steps. You can also do it scripted. So you could run PowerShell scripts that format and partition the USB stick and then apply a WIM to it and run BCD boot to set it up as bootable. So there are plenty of choices on how to deploy it. Generally, it depends on how you want to provide it to your users. If you want to provide pre-configured sticks so that they don't need to do anything, generally you create one using whatever method you prefer and then use a duplicator, or even just buy them pre-configured. So configure one, send it off to the vendor, have them create 500 more of them and send them back to you. Or you can buy a $150 USB duplicator where you stick a master in and then just keep sticking more sticks into it, and it just keeps making copies. You do that before it's booted up for the first time, so before it's been specialized, but you can just duplicate as many of those as you want.
Can you limit 3CCM the sticks that you choose? Like, you want secure sticks like the IP one? Can you pick and choose what sticks for it?
I don't believe Configuration Manager provides any mechanism to force a particular type of stick. Basically, it will validate that it meets the Windows to Go logo requirements, but it won't differentiate beyond that. Okay, any other questions? The only other thing that I forgot to show before, which we can glance at real quickly here, is the actual command to install Windows 8.1 is fairly straightforward. We just need to specify right there, setup.exe/auto:upgrade. We've created a package that contains the full Windows 8.1 media, which is about 2 gigabytes worth of stuff. And we push that out to the machine, specifying that it be downloaded locally and then executed from the local cache. So that way we can make sure that the process doesn't start until all the bits are available locally, and once it starts, it can run through to completion without any more network activity. Let's see how our deployment's actually doing. Still working on both sides, so it'll probably take it another 20-25 minutes or so, but easy enough to go through the process whether we're coming from Windows